Yes, hi. My name is Dainis Krūze. I am co-founder and CEO of Aerones, and we basically disrupt how the wind turbines are being inspected and maintained. So it all started with two people, like founders, of course, me and Dainis. We thought that we will build heavy lift drones and get rich from them. And so so we started with a drone which could lift 20 kilos. And then we built a drone which were able to lift 200 kilos. We did a lot of testing in fun way. But we understood that the drone works. It's nice, it's working, it's good. And then we started to search for proper market fit, where we will use it. We thought that the heavy lift drones will be the things with which we will bring stuff from one point to another. So delivery drones. We thought that these huge drones could do a lot of things in search and rescue people from dangerous places. We thought that the drones will be the future of transportation. We'll see all of those trials here now. And we were right. That's going to be the future. But we were way too early. The batteries were not there yet. Regulatory was not there yet. We wouldn't be able to get any permits to fly, to do anything like even for testing. Yeah, we understood we are too early. The taxi drones will be the future after 5-10 years, but we need a really deep pockets to sustain a company for 5-10 years without having revenue. So we were thinking like, hey, where we could use the drone to do something where the permits will be issued and the batteries will not be an issue. So we tethered the drone. We brought the electricity from the ground to the drone, and we created a drone which was able to fly in the sky indefinitely. Basically, we could fly for hours and do something for hours. So what we did, we built a firefighting drone. So we thought that this is the future of the firefighting. You know, like there's a dangerous place, we don't want to send, something might explode, we don't want to send a human, we will send a drone. Or actually the skyscrapers. The drones could get much higher than the highest ladders in the world. So we could do the skyscraper firefighting. And we built it. We built it, we did the trials. It actually worked. We thought that, hey, this is nice, this is the future. But you talk to VCs, and they're like, how big is the firefighting drone industry? It's not investable. Again, this is going to be a future, but not now. And in one exhibition, like luckily, one guy came to us and he's like, hey guys, you will take my job away. We asked why. He said like, I'm cleaning wind turbines from the helicopter. You could do that by the drone. And so we built a drone to clean the turbines and to do the icing of the turbines. And then we started to investigate what else could we do with the drones, with heavy lift drones, with smaller drones on the turbines. And there were a lot of things which could be done. Cleaning, de-icing, lightning protection system test, painting, a lot of stuff. And then we started to build that. But the drone was all the time, there were things when we needed to touch the blade. We needed actually to touch the blade. But the drone is still swimming a little bit in the air. So we created 3 winches, which were kind of centering the drone in the air. So it's not swimming anymore. So it's like standing steady there. And then one day, Dainis comes to me and he says like, Dainis, if we put another winch over the turbine, we don't need the drone anymore. We just leave the robotic arm in the middle. We can do a lot more stuff on the turbines. It's a lot more steadier, it's faster, it's easier to build, it's cheaper. And that was a moment when we were not sleeping for a few days, like damn, should we, stay in love with our technology of the drones because we've built a cool drone, really cool, like the strongest drone in the world, and search for another proper market fit, or actually switch to robotics and continue with the wind industry. And the decision was, and I always will suggest to anyone, stick to the problem. Stick to the problem which you actually can solve. And we stick to the problem, and we chose to continue with robotics, and now the drones are hanging at our factory at the ceilings. So we investigated the wind industry. So what we understood, to reach zero carbon emission, world needs to switch to renewables. If world wants to switch to renewables, there is an agreement, Paris Agreement, where a lot of developed countries have signed that they are switching to the renewables. So we need to build a lot more renewable energy. We will drive a lot more electric cars, so the energy consumption in the world will double in next 30 years, at least double. So the two biggest technologies to actually achieve more energy and more renewable energy is wind plus solar. Why plus? Because this is Britain. You see, when January, February, March, there is less wind, there is a lot of wind, but practically no sun. Also October, November, December. But when there is a lot more sun, there is a lot less wind. So they are complementary technologies. So the wind will be always built together with the solar to compensate each other. Wind will grow approximately 10 times. Turbines will become bigger. Every 10% in length of the blade gives them 20% in efficiency. So this is why they want the turbines to become bigger and bigger and bigger. But the bigger the turbines, the more expensive the downtime of the turbine because of the maintenance and inspection and repairs, etc. So the biggest turbines right now are producing 1,500 euros per working hour. And the turbines of the future will produce even more, up to 6,000 euros per hour. So the downtime costs more and more. You see the actual size of the turbines being built right now. But the bigger the turbines, the bigger the blades, the bigger the problems. There's the high structures wherever they are, lightning is damaging them a lot. One building is receiving one lightning strike in 5 years. Turbines are receiving hundreds of lightning strikes per year in some of the regions. Bugs, dust, dirt, algae, resin on the leading edge of the blade is reducing the efficiency. When the icing is happening, turbines are stopped. They're producing nothing. Leading edge erosion, turbines are spinning with 360 kilometers an hour, so whatever hits it hard. So the water in the air is actually working like a sandpaper on the surface of the blade. They twist, they bend, they stretch, so they crack. And there are happening a lot of oil leakages on the blade, on the turbines from the hydraulic systems, which needs to be cleaned. So believe me or not, those huge structures, all of the maintenance and repairs are being done by people hanging in ropes, doing that by hand. It's ridiculous. It was okay when the blades were 30 meters long and the turbines were maybe 100 meters high. Now when the turbines are 400 meters high and the blades are 120 meters, it's ridiculous. So some automation is inevitable, and here is Aerones coming and solving the problem. So 2019, we started to trial out these winch systems and robot. 2020, we actually started to do the job on real turbines, working during the day, repairing the robot during the night, improving during the weekends. So basically, that was the path how we were doing the job, and we succeeded. The customers started to believe that, hey, it might work. In 2021, we had 2 robots in the beginning of the year. We started to add more services, more valuable services to the customers and so on. Customers started to believe, order more. We were becoming faster and faster by automating the robot, by automating the processes, procedures in the field and so on. And now we are scaling rapidly. Starting from July, we have scaled a lot. You will see that. So how our system actually works. So we put 4 winches on the ground and a robotic arm platform in the middle. So the first winch is pulling the robot up and down. Rest of the 3 winches are adjusting where the robot is in horizontal space. It's kind of a 3D printer upside down. So we can move with 4 meters per second speed. Rope technicians, when they need to move from one point to another, like half a meter or a meter, it takes sometimes several minutes. We can move 4 meters per second. So we are not limited in our movements, we are not limited in our actions. And in the middle, we change different kind of arms to do different kind of tasks: sanding, grinding, painting, cleaning, lightning protection system test, visual inspection, ultrasound, etc. So there are winches, there are robotic platform, and here's the human. Human sits in comfortable chair, controlling the robot remotely. The automation of everything is to the level now that any guy who has played PlayStation learns to control this robot in 5 minutes, even less. The winches, simply to use, just put in one place, plug one connector, and it works. So currently, the guys are working on the field, one team with one robot, bringing, installing, controlling in the same place. When the Starlink will be up and running, we will control the robots remotely. So basically, the teams will put one robot after another to one turbine, second turbine, third turbine, and we from the office, we will control the robots and control it. And some of the things can be automated to the level that the robot is doing the job itself. About the tool base, yes. So the robotic system in the middle, it's a tool base, and with exchangeable arms, which are doing different kind of tasks: filler application, painting, tape remove, or grinder, or lightning protection system test, and etc. So we have robots for inspections, we have robots for repair, we have robots for cleaning, and we built also, just to complete the bundles, you see one robot outside, which is visual inspection without stopping the turbine, and we have a lot smaller car, which we send in, like crawler, which we send inside of the blade to perform visual inspections from inside, like digital twins. So this system is a lot more safer. Nobody's dangling in the ropes anymore. On average, we do the job approximately 6 times faster. It's scalable. To train one rope technician, it takes months, several months. To train one guy to control this, few days. Any guy PlayStation, 2 minutes. Durability, we can work in a lot higher wind speeds. We are not risking the life, so we basically don't have idle stay days in our projects, and it's more cost efficient. Blades are subjects of damages. It needs to be repaired. Yeah, so they are the highest structures wherever they are. So the lightning is striking them a lot. We've tested more than 2,000 turbines right now. More than 20% of the turbines, lightning protection system is not working properly. It's not protected against the lightning. The highest expense for the insurance in insurance cases are because of the lightning. Why it's not being tested, why it's not being repaired? Because it's too expensive. To test one turbine with humans, it's more than a day. Blade internal inspections. Every crack, every blade who has fallen down because it's snapped off, it's because small crack became bigger and bigger and bigger while it snapped off. So we're searching for the cracks before they have grown. We want to track, we want to find those cracks while they're small. So a fast solution to do the internal inspection and visual inspection of the blades to find the smallest crack on the blade is very important. So for the humans to perform internal inspection of the blade takes 1 day. For this robot, approximately 2 hours. Visual inspection, again, we don't even need to stop the turbine. We do the visual inspection of the blade, of all 3 blades, without stopping the turbine. So 0 downtime visual inspection. And we are working towards now, with Force technology, we are working towards ultrasound inspection. Basically, ultrasound is scanning through the fibers of the blades. So every crack starts with an air bubble, a small bubble between the layers. So we want to find these cracks before they have actually became the cracks. We have a lot of data. So our robotic company is now switching towards also the software company. So we're building a huge platform. We have a lot more data than anyone else about the health condition of the blades of the turbines. So we are building the platform where we are analyzing the data from our inspections. We are doing the suggestions, what should be done about every single problem we find, and the customers getting the full budget of how to maintain and how to do the repairs, how much it costs, do the tenders and task management for the technicians, and etc. And then we understood that, hey, we are doing great job on inspections, but we are only bad news deliverers. So we want to solve some problems as well, right? So we started with maintenance. We created the robots to clean bugs, dust, dirt, algae from the leading edge of the blades, which is reducing approximately 2% of efficiency of entire industry. So we are doing the job approximately, again, 6 to 9 times faster than the human. Oil leakages which are happening on the towers needs to be cleaned off as well. Again, humans need approximately 3 to 6 days to stop the turbine to clean one tower. We need approximately 5 hours. So the downtime costs €1,500, in the future 6,000 euros. So you can estimate that the actually expense of the downtime of the turbine is more expensive than the human labor on the turbines. So we are changing that. We are changing that the downtime of the turbine during the maintenance is less and less, and we are improving the efficiency. Leading edge erosion. Leading edge erosion is happening to every single blade in the world. So it goes from this to this. Efficiency drops down. Basically, sharp knife versus not sharp knife. So when the efficiency is dropping down, they are repairing, and then the cycle continues. All industry is losing approximately from 6 to 12% in these small teeth, which are basically cutting inside of entire production. So to repair this versus this, for the humans, that area which needs to be repaired on 70 meters long blade, it happens, for example, for 25 meters, it takes from 6 days to 12 days. It doesn't matter which level of erosion has happened. So it's too expensive, so they don't do that. Our robot can do the job in less than a day. Again, we are saving valuable downtime. We are saving the efficiency of entire industry by 6 to 12%. It's very important. So we do the sanding and grinding. We apply the filler, and we do the painting of the blades 6 to 9 times faster than the human can do that. Icing, when icing is happening, the turbines needs to be stopped. There is a treatment. You can apply ice-phobic coatings, which are preventing for the ice to structure. Again, for the humans to do that, it's approximately 6 days per turbine. We can do in 1 day. It needs to be done every 2 or 3 years. So again, it's not being done because it's by the humans. It's too expensive and not efficient. We are bringing the technology to actually be able to do that a lot faster and actually in a lot better quality than the humans can do. And all industry is moving towards the offshore. We will see a lot of turbines being built in the offshore. So we actually got also a European grant, and now we're building also the offshore solution. It's another delivery system. It's not the winch system. It's this, like a crawler and magnets, which is walking towards the tower of the blade. But in the tip of the system, we can put any single arm which we already use in the onshore. We will be able to use also in the offshore. So we will be operational in the offshore in the next year's summer, 2023, sorry. So this is a robot which is doing we are trialing it already out in the onshore. So yeah, we started as a small team. And as I already said, in July, the big turning point was in 2021, July, when the customers started to understand that, hey, it works, and now we're already 150 people. We have experienced a huge growth in last half a year. Yeah, we have robots right now, shipping new robot every week, if not 2 robots a week. But we have robots in Latin America, in South America, in North America, in all over Europe. Our customer base is growing every week. We are approved by the largest manufacturers of the turbines, Vestas, GE, Siemens Gamesa, and we are as certified service providers for from top 100 companies in the world. We are working with 70 of them. We just raised $9 million to run faster, yeah, our goal is to increase wind energy efficiency by 6 to 12%. It's actually doable. We're actually doing that. We will do that. And yeah, to help the world become zero emission faster. Thank you.